Okay, so this is assuming that for the project you've already got your data in, you've drawn a graph using Excel or your graphic calculator, and you've got an equation of the line, you've taken outliers out and those kind of things. So let's presume that your equation of the line is y equals 2x plus 2. And you're looking over here, you're saying, okay, if I've got 300 grams of protein, what size egg am I going to get? Okay, what size egg am I going to get across here? Now, this is outside of your data, okay? So you're extrapolating your data, you're making a prediction. So you substitute in y equals that, therefore y equals 602 grams for an egg, okay? This is your egg here. So you need to be aware that if you extrapolate your data and you go out a long way, you're going to come up with an answer that may be nonsensical. So is it a reasonable? Is it reasonable? Reasonable. And what's the limitation of this? Of this data. I mean, again, you can't say that you're going to get an egg that's only half a kilo out of a chicken if you give them 300 grams. So you've got to be realistic with what you are finding. So, okay, that's the first thing. Now, you're working with your critical friends. They've done Chicken Life, which is in green here, and you've done the other one. So you're trying to find out a prediction here that fits in there for the optimum amount of protein that gives you chicken life and egg weight. So let's pretend that you've still got the equation from the other one for the protein and egg weight, and it's y equals 2x plus 2. And you might say, okay, I want to have an egg, I want an egg over here that's 100 grams, because 100 grams is a good size egg to have. So that's your y value. So you put in 100 equals 2x plus 2. You want to rearrange that. So x will equal 100, take 2 over 2, which gives you a grand total of 98 over 2, which will give you a grand total of 49 grams of protein to produce an egg that size. Now, we want to work out what that does for the lifespan of the chicken. So your partner will have a formula for that line, and they might have something like y equals 0.1x plus 55 or something. I just made these up, okay? So now we take this value here, which is the grams that we got for the egg that we want, put it into here. And you'll end up with 59.9 days. So if you're going to put in, if you want an egg that's worth 100, okay, so you're wanting an egg that's going to be 100 grams, we've worked out that you need 49 grams of protein for the chicken for that. Now, if you're putting 49 grams of protein, how long does it last for? You've grabbed the equation for the lifespan of the chicken from your friend, you've substituted in this value of x, and you've worked out it's going to be 59.9 days. Now, you'll have to discuss, once again, you're going to have to discuss the reasonableness of this solution, and is there a limitation to what you've found? So these are two things you're going to have to discuss when you're doing your findings. Okay, and this will be different for everyone, but that's basically showing you that you've extrapolated your data, you've then come back in to find the optimum solution that you think for you and your pair, and you're going to work out if that's reasonable. And then from that, you can talk about whether your data is good and what you would do in the future to refine this process. Cool.